Day 49 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're on day 49. If this is you guys' first time on this channel, welcome, welcome, welcome. We're doing a LeetCode problem every day until I get a job, or until we get a job, or until, we just don't feel like doing LeetCode anymore, guys. So right now we're on day 49. We're in the middle of the LeetCode 75, guys. So if you want to get caught up on the LeetCode 75, you can check the previous videos out, and we've been doing the LeetCode Problem 75 for a couple weeks now. And so, yeah, guys, don't forget though. Don't forget, bring a mouse, 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 bring it right over here, guys, and click that subscribe button for me. And then after you click that subscribe button, go ahead and hit the like button for me too. Then after you hit that like button, shoot, you might as well go ahead and drop that bank emoji in the comments. All of my bankers out there, go ahead and drop that bank emoji in the comments for me so we could grow this Swift community and get this Swift codes and stuff into the algorithm, so we could bring Swift awareness to more people and we could get more people involved in Swift. Now, with that being said, guys, let's look at the question we have here today. Today we have question number 872, leaf similar trees. The difficulty level is easy, guys. So the guys who already been here, they already know we're going to keep the solution as simple and easy as possible, because we're all trying to learn here. And if you can't understand the solution, then it's going to make it more difficult to learn. So we're going to keep the solution as simple and easy as possible. And let's see what the question says. It says, consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. So it says, for example, in the given tree above, the leaf value sequence is 6, 7, 4, 9, and 8. Two binary trees are considered leaf similar if their leaf value sequence is the same. Return true if and only if the two given trees with head nodes root 1 and root 2 are leaf similar. So let's see what they mean by that in example 1. So in example 1, you could look here. We just want the leaf node. So the leaf node is a node with no children, right? So this 6 has no children. This 7 has no children. This 4 has no children. This 9 has no children. And this 8 has no children. So it goes 6, 7, 4, 9, and 8. Then if you look at this tree right here, it's the same thing. This 6 has no children, this 7 has no children, this 4 has no children, this 9 has no children, and this 8 has no children. And if you look and you compare the two, it goes 6, 7, 4, 9, 8. Then you look over here, it goes 6, 7, 4, 9, 8, and that is why the output is true. So let's look at example 2 and see, because this way you might get confused and you'll see it returns false. But you look at this one, it has a 2 and a 3, and then this one has a 3 and a 2, and that returns false because the 2 and a 3 and 3 and 2, there's two different orders, there's two different sequences, so we're returning false. We want the same sequence, guys, so just remember that when we're writing the code. Now, with that being said, let's get started on the code. Like I said, guys, it's not that difficult, but hey, we're going to make it do what it do. First thing we're going to do is we're going to create a helper function, and we're going to call that function get leaves, right? And that is going to have a root, and that root is going to be a tree node. We're going to put a question mark there, and it is going to return an array of integers. Excuse me, guys, because we want to return that. Then we're going to come down here, and we are going to say guard let root equal root, else. Oh man, guys, typos everywhere. Else we're going to return a blank array. Then we're going to come down here, and we are going to say, no, we're going to declare a variable called res for result, show for result, and then we are going to say, we're going to cast that as an array of integers, and we are going to initialize that with a blank array, guys. Then we're going to come down here and we're going to say if root dot left equals nil, comma, root dot right equals nil, then what we are going to do is we are going to come down here and we're going to say return, open up the array brackets, say root dot val. Then we're going to come down here, we're going to do it again, and we are going to say, this time it's going to be an if let. We're going to say if let L equals root dot left. We're going to say res plus equals get leaf L. Then we're going to do the same thing down here for the right, and we're going to say if let R equals root dot right. Oh, excuse me, guys. If the root dot right, we are going to say res plus equals get leaves parentheses R. And then we're just going to come down here and we're going to say return res, guys. And then we're going to come up here to the original function and we are going to call that function by saying return get leaves, excuse me, root 1, excuse me, guys, oh man, all these typos is crazy, is equal to get leaves root 2. Then we're going to run that, guys, and let's see what happens. And it's accepted, guys, first time. That's what I'm talking about. No matter how, from what I've noticed, no matter how long you've been coding, you still get excited the first time if your code runs on the first time, guys. So hey, that's something to be excited about, always, in my opinion. Let's see what his numbers looking like. Okay, 7 milliseconds beats 20.12% of users in Swift, but it could be better, guys, but like I said, we want to keep these solutions as simple and easy as possible so that we could at least understand the logic of how things work. Here's the code one more time for you guys so you can see. And I will see you guys tomorrow, guys, for another day, another LeetCode problem. See you then.